Hi. In this video, I'm taking you through some research that was done by one of our early ML engineers in the first year that they were with us with Maxwell Plus. An interesting exploration into how AI-based super resolution could be used to help improve the accuracy of segmentation algorithms of MRI of the prostate. So this work used a deep learning algorithm, we'll go into the details on that shortly, to try and improve how easily 1.5 Tesla MRI scans could be segmented and bring that up to the sort of quality and repeatability we could see in modern 3 Tesla MRI. So a little bit of context about different terms that make it into this work. So segmentation, for those not familiar, is outlining key areas within an image. In the case of prostate MRI and Maxwell Plus, we segment the entire prostate into a number of different anatomical zones, which can help with differential diagnosis and be used as key indicators of where cancer might be, as well as segmenting potentially cancerous lesions. This work was looking at that first example, the anatomical segmentation of the prostate. The second topic that's relevant to this work is the idea of super resolution. It's an idea that has been around for some time, but what it's about is using artificial intelligence in this case, but any technique really, that can increase the detail present in an image. And the term comes from the idea that you're trying to replicate what an image would look like if it was captured at a higher resolution. Now, in the field of MRI imaging, there's more to image quality and resolution than the field strength, the 1.5 Tesla versus the 3 Tesla, but it's a big contributor. So let's get into the details. How did this algorithm work? So this algorithm used what's become quite popular today, which is adversarial networks. In this case, a modified generative adversarial network that was trained to take 1.5 Tesla MRI scans, an individual slice in that image, pass it through a UNet type architecture to produce what we call the enhanced 1.5T scan. Now these were at a higher resolution, and the goal there was to also increase the sharpness and the detail and ultimately the applicability to the segmentation algorithm. Now the way that was trained is that a discriminator, a network that looks at images, was either given a real 3 Tesla MRI from a random patient or given one of these enhanced 1.5 Tesla images, and over time it was told to pick out the real versus the fake, and that helped the enhancement network slowly get better at generating artificial images. Now we can see here some examples of those enhanced images. We have the 1.5 Tesla prostate MRI at the top from different sections in the prostate, and the enhanced image below. Now it can be a little hard to see in this video, but we saw improvements in things like sharpness and contrast in many areas within the image, and in the end it did provide a small boost to the segmentation algorithm. Now these days in clinical practice, many modern 1.5 Tesla machines produce great image quality, very suitable for segmentation algorithms, but technologies like this help to level the playing field, especially in areas which may have older systems or limited access to more modern machines. And this technique of enhancing images or capturing these images has been used in many ways outside of Maxwell Plus. There's a wonderful company in the US called Subtle Medical that is looking at speeding up MRI acquisition time by capturing less data and recreating the full scan. And in another context, it's looking at PET scans, positron emission tomography, and using less of the compounds needed for that type of imaging whilst still maintaining a very high quality image. Fantastic company, really interesting use case of this technology, and really shows how artificial intelligence in the medical field can span everything from the detection to the diagnosis, to even improving the quality and the speed of these techniques. So that's it for this one. Nice and short. This was a wonderful piece of work. Very interesting proof of concept to say that MRI data can be shifted and improved through technologies like AI for super resolution, and ultimately to make them more applicable to other AI algorithms, including segmentation, which we'll touch on in another video. That's all for this time. Until next time, thanks for tuning in.